The most distant human-made object is NASA's Voyager 1 spacecraft, which has managed to reach interstellar space. Imagine launching a spacecraft 45 years ago, and still exploring areas it was never thought to reach, well beyond its scheduled lifespan. That's the incredible reality of a bold NASA mission that is redefining space exploration. But there's something even more fascinating. This brave spacecraft is not only millions of miles from its launch point but continues to send data back to Earth using technology older than that of a cassette player. That's not all. The spacecraft, launched in 1977, just made a discovery that has shaken the scientific community and captured the attention of the entire world. What could this amazing find in the far reaches of space be, and what does it mean for us here on Earth? There was a key moment in history when two of the most amazing space missions ever launched ushered in the era of space exploration. It was thanks to the brilliant mind of Gary Flandreau of NASA's Jet Propulsion Laboratory that an ideal route was mapped out for the probes to reach the distant planets, Jupiter, Saturn, Uranus, and Neptune. With only a pencil and a 21st century engineering tool, Flandreau made a startling discovery. In the late 1970s and early 1980s, the four gas giants would be aligned in a unique cosmic configuration, creating a kind of celestial necklace with Earth. This would allow spacecraft passing close to each planet to gain speed thanks to its gravity, as if it were being pulled by an invisible rope. Thanks to this gravitational assist, a journey that would normally have taken 30 years from Earth to Neptune would be reduced to just 12 years. However, there was a catch. This alignment occurred only once every 176 years. Faced with such an exceptional opportunity, NASA acted quickly, and just 15 days apart, they launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977 with the aim of taking advantage of this cosmic alignment. Little did they know then that these twin explorers would break all records in the history of space missions. More than 45 years after launch, the Voyager 1 and Voyager 2 spacecraft are still operational, sending back information daily from the edges of our solar system. These probes have become the farthest human-made objects in history, having traveled far beyond what was first imagined. This is impressive when you consider that their original mission was planned to last just 4 years. However, these interstellar pioneers had plenty of surprises in store. At the start of their epic journeys, they gave us incredible close-up images of the moons of Jupiter and Saturn, revealing worlds far more active and dynamic than anticipated. The discoveries of active volcanoes and vast ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to approach Uranus in 1986 and Neptune in 1989, becoming the only probe to have ever visited those planets. It surprised scientists with astonishing findings in previously unexplored territories. More than 14 billion kilometers from Earth, these Volkswagen Beetle-sized probes have defied all expectations and continue to expand the boundaries of our knowledge. Voyager 1's journey began with a gravity assist maneuver around Venus, a feat never before attempted by any spacecraft en route to Mercury, making it a true pioneer. The journey to Jupiter took the spacecraft 10 times the distance between Mercury and Earth, forcing it to pass through the dangerous asteroid belt, a feat previously tackled only by Pioneer 10 and 11 probes. But the challenges didn't end there. With just 69 kilobytes of memory, a fraction of the capacity of a modern smartphone, the onboard computers had to rely on their own intelligence to manage the complexities of this extraordinary journey. Data collected by instruments aboard Voyager was stored on track tape recorders before being transmitted to Earth via a transmitter that used only 23 watts, about the same power as a light bulb. These probes were equipped with 12-foot diameter satellite dishes to facilitate communications. They used light-speed radio signals to send and receive messages, but the increasing distance from Earth, an advance of 3 or 4 light seconds each day, presented major challenges. One of those challenges was that signals from Voyager 2 took more than 18 hours to reach Earth, and increasing background noise from radios, televisions, cell phones, and other sources made it increasingly difficult to pick up the faint signals from the spacecraft. Despite these obstacles, the Voyager probes have defied expectations and continue to amaze astronomers with unexpected discoveries in interstellar space. Their journey has rewritten our understanding of the cosmos, and altered our view of the unknown. Beyond our own solar system lies the enigmatic Oort cloud, a vast congregation of comet-like objects held together by the sun's gravity and stretching to the nearest star. Although the Voyagers are still moving slowly towards that distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. This boundary was initially estimated to be about 50 astronomical units from Earth, and so it was decided to continue funding the mission even as the probes neared that milestone. However, crossing this boundary did not immediately detect a significant change in the environment, leaving scientists baffled. The passage into interstellar space was expected to be accompanied by an abrupt increase in the number of cosmic rays, high-energy particles traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. However, most of these high-energy rays are deflected by the magnetic shield generated by the heliosphere, which protects our solar system from most external threats. The Voyager mission team closely monitored any changes in the prevailing magnetic field as the spacecraft moved into the interstellar medium, an environment composed of ionized gases and influenced by nearby stars. The interstellar magnetic field was expected to be oriented differently compared to that of the heliosphere. However, the Voyager probes did not detect any significant changes in the magnetic field. It was on August 25, 2012, that Voyager 1 finally crossed the heliopause and transmitted fascinating data confirming the expected increase in plasma density, although without evidence of a change in magnetic fields. This was surprising, since it had been anticipated that when moving from a region dominated by the Sun's magnetic field to one influenced by other stars, there would be a noticeable variation in the direction of the magnetic field. Voyager 1 has also detected plasma waves in interstellar space, helping scientists understand how charged particles behave in the vast cosmic ocean beyond the solar system. In 2013, it recorded an increase in plasma oscillations, confirming that it had entered a new region of space where the Sun's influence was fading. Furthermore, the probe continues to measure cosmic ray intensity, which has significantly increased since its entry into interstellar space. Another of Voyager 1's most famous contributions to science and humanity was the capture of the pale blue dot image in 1990. At the request of astronomer Carl Sagan, the spacecraft turned its camera back toward Earth from 6 billion kilometers away. The resulting image showed Earth as a tiny speck suspended in a vast cosmic abyss, emphasizing our planet's fragility and insignificance in the grand scale of the universe. Let me know what you think in the comments. If you enjoyed the video, don't forget to hit the like button and subscribe to the channel.